All right, in this video, we're going to talk about how to simplify radicals. And radicals are just sort of this little symbol right here. And really it means what do you multiply by itself to get what's inside, which would be x. One of the properties about radicals that you can write down in your notes is anytime you have two radicals, such as a to the x times b to the y, really these are let's say you're multiplying together. You'll keep a and b on the outside because they're already outside the radical. And what you can do is you can combine the x times y inside the radical. So just one quick property about radicals that you can put on your notes. All right, so how do we go about simplifying something like this? Square root of 1 away. Now you're not going to see this 2 here, but really that 2 represents, because you can have third roots, fourth roots, but if you have a square root, really that means the second root. And the best way to approach this is you want to find pairs. Any pairs that you can find in here, because once again, it's what multiplied by itself. So the way I like to look at it is out here, this would be like a dance floor. This here would be the punch bowl. And I'll explain what I mean by dance floor and punch bowl in a second. So if I want to go ahead and simplify something like square root of 1/8, what I'll do is I use the tree method. There's other methods you can use, but a tree method's a good way. And the tree method is you just sort of make a tree. What can I multiply to get 1 away? Well, that would be 2 times 54. What can I multiply to get 2? Just 1 times 2. It doesn't go any further. But over here, this would be 2 times 27. Well, what can I multiply to get 27? That would be 3 times 9. What would we multiply to get 9? That would be 3 times 3. So with the tree method, we go ahead and we make this out into as far as we can extend it, and then we get, these are our ends, like the end of the branches, and we look at them. And the reason why I call this the dance floor and this is the punch bowl, it's like a slow song comes on. If you have a partner, you get to stay on the dance floor. If you don't have a partner, that's normally when it's a good time to go get some punch. So let's see which ones have partners. In order to have partners, they have to be exactly the same. So these two here, these 2s, they're a partner. I can circle them, I put them on the dance floor. Some people are like, well, how many do I put? Each pair, you only put 1 there. All right, let's look at these 3s. It doesn't matter which ones I pair up, but I also have a pair of 3s. They go on the dance floor. This 3 here has no partner. Sorry, go get some punch. And what you end up getting is 2 times 3 is 6. This would be the simplified form of square root of 1 away. Okay. All right, let's look at another example. 5 square root of 243. Being a big number, it's hard to really think, okay, what can I, the 5 stays on the outside. It's already sort of like on that dance floor here. See if we can add anything else there. But 243 is a big number, so just get your calculator. You can do 243 divided by 2. It's not an even number, so it's not going to work. 243 divided by 3, use your calculator, it actually will work. And you actually get 3 times 81. If it didn't work, keep on doing 4, 5, 6, whatever, and you'll slowly break it down. Once you get to 81, you can do 3 times 27, 9 times 9. Once again, it doesn't matter. In the end, when you bring your tree all the way down, you'll end up getting, in this case, you get 5 3s at the end. So partnering up, here's a pair, dance floor. Another pair, dance floor, and this 3 here, 4 things all by itself, it would go get punched. So what I ended up getting is 5 times 3 times 3, which is 45 square root of 3, and that's your simplified form. All right, a couple more examples here. So this is where now we got to go back to our property. 5 is going to stay out here. But what we can do now is you combine the 12 times 3 under the radical. If you want, you could say square root 36, but we might as well, we're going to be dividing this into a tree, might as well just leave it as 12 times 3, and you can sort of see how you can just continue on. Well, this would be 2 times 6, and this would be 2 times 3. Once again, you could have put this as 3 times 4, and then, it doesn't matter at the end, here's what you'll get. So you'll see I got a pair of 2s here, a pair of 3s here. They go out on the dance floor, and I've got nothing left to put in the radical, and that's fine. So you end up just with 5 times 2 times 3, which would be 30, and since there's nothing on there, you don't have to put the radical. Why don't you, if you want, you can pause the video and try one more example on your own. Okay, so go ahead and pause the video, try this example, and then come back and you can check to see if you did it right. All right, so this last one, you'll see the 2 and the 4, they're already on the dance floor. 3 and 120, they stay there, and we got to go ahead and make our tree. 3 we just leave by itself. 120, well that could be 10 times 12, 2 times 5. This would be 3 times 4, and 2 times 2. So you sort of see I've got all my ends here now. So let's look for pairs. Got a pair of 2s. Goes on the outside. See, I got a 3 here and a 3 here. Not next to each other, it doesn't matter. Goes on the outside. And then I actually have a 2 and a 5 that do not have pairs. So both of them will go get some punch. So then I got 2 times 4 times 2 times 3, which would be 8 times 6, which is 48. And then 2 times 5. And that would be my simplified radical form. All right, you can go ahead then and get started on the homework. And then once you know the homework, there is an answer key with the work worked out for you.